this, that you have a mom whose blood type is A dad that I'm asking you his blood type, and they have a baby whose blood type is O. So my question is, which one of these 4 blood types on the left could not be the dad's blood type? Which one could not be the dad's blood type? So somebody said A. Somebody else said AB. The answer is AB. But all day I have had some people that suggested A or B. Here's the thing. Keep in mind, if mom is blood type A, but her baby is O, what does that tell you about her genotype? Right, she has to be heterozygous. Just because her blood type is A doesn't mean she's not carrying the gene for O. So it's also possible that dad could be blood type A and carry that. He could also be blood type B and carry that. And obviously he could be type O and carry that. What he could not be is AB, because the only code for AB would have him with an A and a B, and therefore he would not be carrying a little I to have a type O baby. So that would be an example. Let's do one more. So let's still have a mom with blood type A. I'm going to erase all of this. This time, instead of the baby being O, I should never, well, it's all right. I'll just leave it. Instead of the baby being O, let's say that the baby is AB. This time, instead of telling me what the dad cannot be, I want you to tell me all the possible blood types he could be. So, can he be blood type A? I'm hearing some no's. More no's than yeses. He cannot be blood type A. Why? Right, because the baby is AB, and we know mom is A. So we know the dad has to be the one giving the B. So, could he be blood type B? Definitely yes. Could he be AB? Yes. And then he could not be O. So he could be either one of these as long as he was carrying a B to give to the baby. Yes. Yeah, so to be, okay, so blood type is an example, and this is important, of what we call multiple alleles. There's 3 alleles for blood type. There's IA, there's IB, and there's little I. On that worksheet, that's what the chinchilla thing is. That last question with all that chinchilla stuff, it was multiple alleles, because there was C, CCH, CA, and CH. Those were all like different alleles, different forms of one gene. So any particular person can only be carrying 2 copies. A and B are codominant. So if you're carrying A or B, they are both going to be dominant over O. So a person whose blood type is A could either be IA, or they could also be IA little I. A person who's B can either be this or this. There's only one code for AB, and there's only one code for O. So there's AB, AB, and O. And that's how your blood types would work. But it's very common that they're going to tell you what the blood type is of the person. You would have to know in your head that that person could be heterozygous. So if they're A or B, they could be carrying little I. Not the case if they're A, B, or O, because there's only one code for those 2 blood types. All right? So the other 2 problems I wanted to go over with you guys today, and I think this is a really good example of some of the harder stuff, are on the optional worksheet. This is number 6 and number 7. So I wanted to show you these. On the short answer, I would not ask you, the short answer will have one simple Mendel cross of some kind. Something where like you cross tall and short plants or whatever. Something that would be no more than 4 boxes, that you would only use 1 letter. It could be incomplete dominance, but it would still be an easy cross. Then there will definitely be a question where I will ask you, like, if the parent is, AA, B, B, C, C, what are the chances of this particular gamete? You know what I'm talking about? Where I say, what are the chances that it gives a little A, a little B, and a little C, or whatever. And then it'll be a question that's a dihybrid cross. That'll be a little harder. It's only 1 point doing the dihybrid cross. So it's not going to be something that's massively long where you have to, work a bunch of stuff out. So here's an example of a really hard one, 6 and 7. So this says that there are 2 genes in peas, the gene C and the gene P, and that both are necessary for flowers to have color. That if either one is absent, the flowers are going to be white. So the thing that's the hardest to me on these problems, the hardest for students, I should say, for these problems, is figuring out what the codes mean. So from this, what I'm reading is that if you're big C, big P, you're going to have color. And if you're little c, little c, little p, or little c, big P, anything, or big C, anything, little p, all of these would code for being white, no color. That's basically what they've said. They've said you have to have a copy of big C and big P for the flowers to show color. Otherwise, the flowers will automatically be white. You with me so far? That's the hardest part. Once you figure out what codes are possible, the rest of the problem is usually not hard. So it says, so they're crossing a heterozygous plant with a little big C, little p, if you can't see from the back. So what would be the genotype of a heterozygous plant? What would be its genotype? Big C, little c, big P, little p. They're just asking to see that you understand what a genotype is and what heterozygous means. All right, and then they ask what's the phenotype of the big C, little p plant. So what will it have color or will it be white? Correct. It will have no color. I'll just put white. So it will be white. That's something you'll have to do in the short answer. I'll give you an explanation and I'll literally just give you a code and ask you what will it look like. And it's just a one-word answer. So you just have to understand how to read the paragraph and figure out what they're asking for. All right, and now they want to know what fraction of the offspring do you expect to have colored flowers. Well, notice what I did here. I know this is the combination necessary for color. So now I'll do my cross. The easiest way to do this is using the product rule. You can use a Punnett square if you want to, but it's usually going to take a lot longer. So first I'm going to cross my C's. Big C, little c with big C, little c. What are the chances from this cross of at least one big C? 3 out of 4. So remember, the code I'm looking for is the fraction of them that are going to be this. Big C, anything, big P, anything. So I know my chances of a big C, anything, are 3/4. Times chances of big P in the offspring. 1/2, right? 1 big P, little p. So 1 out of 2, so 1/2. So my chances of the flowers having color, 3 times 1 is 3, 4 times 2 is 8. My answer is 3/8. And if you were asked, by the way, if you were asked a follow-up question, what fraction of them will be white, don't go work it out again. If 3/8 are colored, how many are white? The other 5/8, because that's the only other option. That's not necessarily always true. Obviously, in some cases, there's more than 2 options. But in this particular problem, everything else would have to be white. All right, so look at this one. Now we get even harder. Same problem. You have to have big C and big P to show color. Little, or little is none. But if they're big R anything, they're going to be red, as long as they have C and P. And if they're little r, they're going to be yellow. So, A is a really good example of something I could ask you on the short answer. So they want to know what color each of these will be. So how about the first one? Big C, big P, little p, big R, little r. This one will be red. Correct. How about the second one? It'll be white. Why? Because of the little p's. How about the third one? Yellow. It's got capital C and capital P, but little r. So this one would be yellow. And the last one? White, because it's got little c's. So this would be something I could definitely ask you. Can you take the information and just look at something and tell me what color it would be? All right, and the last one, what are the chances of yellow flowers from this particular cross? So we know to be yellow, it has to have a capital C, a capital P, and then what does it have to have for the R's? 2 little ones, right? So this is what we're looking for, the chance of this combination. Now it's easy. It's just the same product rule. Cross our C's, what are the chances of a capital C? 1/2. Cross our P's, what are the chances of a capital P? 1/2 again. And cross our R's, what are our chances of little r? Only this one. So 1/4. So our answer here, 1/16. And this one would not be all the 15/16 would be the other color, because there are 3 options. I could ask you what are the chances of red, and instead of using 1/4 here, you'd use 3/4, because it would be a 3/4 chance of red. Yes?
So instead of it being yellow, let's say it was red, it would be C, whichever upper score is, and then at the end it would be have it orange.
3/4 instead of 1/4.
Okay, yeah.
And then, so you'd end up with 3/16. And then all the rest would end up being white. So that's a much harder problem. I would say that the ones I have on the test are not that hard. First of all, this has 3 genes, and I don't have anything on the test on the short answer anyway with more than 2. But if you understood this one, I mean, this is, like I said, then you definitely get it, because this is like much higher level than most of the questions on the test are. So that's it. I would highly recommend